Okay, so we discussed about the supervised machine learning so far. Okay, so what exactly the machine learning algorithm is all about? What is machine learning? Anybody remembers that? I just take that thing here. We discussed about so without writing programs explicitly, we train the model with the historical data. Okay. So once the model get trained with the historical data, we apply the model on the unseen data. That is what machine learning is all about. That's what we discussed. Exactly, Roshan. You're correct, right? Yeah. So what is machine learning? Without writing programs explicitly. You can see a lot of definition around in the internet, but this is the most apt one. Without writing programs explicitly, we train the model with historical data. Historical data. So historical data in the sense both historical data should contain both input and output features. Give me examples for input and output features. We discussed last week, right? Input and output features. Both input and output features. The historical data should contain both input and output feature. Okay, and yeah, right. So so apply this train model on the unseen data. It's something like input is a question and output is your answer, question and answer. You train the model with both the input and output features. For example, um, let's you are my student, right? I train you both the questions and answers also. So for this question, this is the answer. For this question, this is the answer. This is how you need to answer it. Let's say you are attending an interview tomorrow or day after tomorrow. You're asking me what kind of questions that you can expect. I say this is the question, these are the questions that you can expect, and these are the answers for that, right? So that is right. Once I give you the both the question and answers, right? But see, the typically college time and school time, what we do, the previous batch, the question papers we take it and then we'll prepare it well. Okay. And then, right, with that questions, previous batch questions and answers, what we do is we will prepare for the current, current batch or the current year exams, right? So in the exam, you cannot expect the same questions from the examiners, right? So they may ask different questions also than the questions whatever in the previous batch students they studied, right? So but you are referring multiple batches, multiple previous years question answers. In that case, right, even though in the current year exam they ask different questions, right? Still you'll be able to answer it. Okay, you should be able to answer it. So only then we can say that you generalize the concept very well. So rather than memorizing the concepts, you are generalizing because the same questions, but this year they ask the same question in a tricky way. Still, you should be able to answer the tricky question with the correct answer because the same question you prepared it. You went through the same question in the past batches, exams, right? Previous year exams questions, you went through that. But the same question, but they asked in a tricky way. Still, you should be able to understand. You should be able to answer it correctly. But because you know the question and you know the answer, and but this time the same question they asked it in a tricky way, the answer remains same only. But you should be able to understand the tricky question is nothing but the same question which we prepared it for the previous. We prepared it during the preparation time. It's something like, right, instead of memorizing, மக்க படிக்கிறத விட நம்ம வந்து அதை புரிஞ்சுக்கிட்டு படிச்சுக்கிட்டோம்னா நம்ம என்ன பண்ணுறோம்னா நம்ம வந்து தப்பே பண்ண மாட்டோம் இல்லையா? ஸோ அதே தான் சேம் பிரின்சிபல் ஹியர். ஸோ ஹியர் it is a responsibility of the data scientist to make sure that the model generalizes well, even if the model, even if you apply the model on any unseen data, it should predict with more accuracy. Okay. There are types of machine learning algorithm, types of machine learning algorithm, types of machine learning algorithms. One is supervised, and the second one is unsupervised. Third is semi-supervised. And fourth one is reinforcement. Right? Supervised machine learning. Supervised machine learning. Okay, and then unsupervised machine learning, reinforcement machine learning. What is supervised machine learning? So what you learned is called your supervised machine learning. So the one we discussed, right? The bank example. You have set of input features. You have an historical data related to bank. So here, 1 second, some echo is there, right? 1 second, I'll just. Okay, you have okay, still, hello. Still not getting the info. Okay, please bear with me. Probably in the next session, I will just take care of it. I think some problem with my system. Okay, so what is machine learning under algorithm? You understood that if there are 4 different types of machine learning algorithms are there. One is supervised, another one is unsupervised, and semi-supervised, and is reinforcement. Okay, what is supervised machine learning algorithm? The one we have seen it is called your supervised machine learning algorithm. Okay. Okay, so what is an example for that? The same data whatever the data we discussed as part of banking example, right? So the historical data should contain both the input and output features. Input and output features. So in practice, they call it the input features and labeled output features. So the input features are this one. What is the input one is loan application number, and then loan date and age of the customer, and then loan amount. The additional income, marital status, own house. These are called your input features. These are called your input features. What is the labeled output feature here? E is default. Okay. With these features, we are going to derive the E is default, right? In the historical data, it should contain both the input feature as well as the label feature. If so and so thing is there, this is called your simple thing. If let's say take for example the orange fruit, right? or a color of the fruit and the size of the fruit, shape of the fruit. The shape is round and the color is orange, and if the taste is something like this, right? Then it is called orange. Okay. And similarly, apple, right? So the color is red and the shape is something round, and the shape and color, and yeah. So, and this is called apple. Similarly, here, these are the input features. This is where label output feature. So, the age of the person, a person with 30 years, and his income is 20,000, and he is owning a house. He is a bachelor, unmarried guy. And in the past, he did not default. These default contain either yes or no, right? Some customer, defaulted. Some customer they did not default. Okay, N, all right. So you just think, this column is also there next to this one, input features. Okay. So your model has to predict this labeled output column. Okay. So here you have the historical data, you train the model. Okay. The age of the person, all the things, right? You have listed 10 records are there. 10 persons, 10 customers, 10 customers age, 10 customers income, everything. Okay. And each default is on the past, right? Based in the past, let's say, you have 10,000 customers data, you took it. So people with so and so age, people with so and so income and marital status, they defaulted. Some customers they did not default. All the historical data you take it. The historical data consists of both input as well as labeled output features. So this is your historical data. Once you take the historical data and train your model, you apply this train model on the unseen data. The historical data consists of both the input and output features, label output features. So these are the example for the input feature. These are the label output feature. You train the model with both the input and output feature. But input features, if you see, more number of features are there, but labeled output feature is only one column, right? So here, now this is step one. There's nothing but historical data. Okay, again, historical data. And then once you train the model, apply this trained model on the unseen data. So what in the unseen data? The unseen data contain the same input features, but it will not contain the output feature. The classic example is new customers. Okay, so these are the past customers, previous customers, how much money they borrowed, and whether they made the payment or not. Okay, this is the thing you have it. This is the thing that you trained your model. So next thing is you apply this trained model on the unseen data. Let's say a new customer applies for the loan. What you do is you apply the model, trained model on this unseen data. The model can, the model has to predict the each default based on the patterns it got learned from the past. The trained model, has to predict the each default column. If I give any customer with these details, it should say, hey, this is the one here. Okay. It's something like this. See, let's say somebody tells you with 2,000 square feet house in Chennai, Adyar, in Chennai, in Adyar, 2,000 square feet house costs this much. The output feature is your numerical column in that case. Okay. So in this case, the label output feature is default is a binary column. Okay, binary column. Somebody tells you input features are like size of the house, location of the house, and the age of the house. They tell you for this age of the house, for this location, for this carpet, this is the price. And again the same location. There is a slighter variation, 1,800 square feet, and and size is the age of the house, this one, and all the things they tell you. And for this is the size. Okay. In that case, what you do, right? If I give some new specifications, input features. So, okay, tell me, if the age of the house is 10-year-old, and the size of the house is almost 2000, almost 1998 square feet, and the location is Adyar. Obviously, it's something closer to the one which you trained your model, right? So previously you trained the model with the same input features. The corresponding output feature is the price, housing price. In that case, the numerical variable, the label output feature. Remember that the label output feature can be a text to column or a binary output, right? Or it can be a multi-class output variable. Okay, either binary yes or no, or it can have more than two values also, but it's a categorical column. Okay, you're predicting the categorical column. Okay, and in the case of housing price prediction, the price is your output variable. That is what you are predicting it. Okay, but this given specifications, the size, age, and location of the house, this is the price. Right, you train the model with these features. Even if I tell you the same thing, right? In so and so area, in the Adyar location, square feet is 2000, and age of the house is 10 year. It costs, let's 2.5 crore. Okay, 2.5 crore. Similarly, right, let's if the other customer asks you, because already your brain knows this one, but this specification, this is the price. Okay, somebody comes back and asks you the same question. Let's the size of the house is 1998 square feet, and age is 10-year-old, and the location is Adyar. Can you please predict and tell me what is the housing price? So you can say somewhat closer to 2.5 crore, right? You can tell. Same thing is applicable here. Once you get trained, right? So when somebody asks the questions, if they give the same specification or somewhat similar to the specification, still your model should be able to make a prediction. It should give the predicted value. Okay. So why it is called supervised machine learning algorithm? Why it is called supervised machine learning algorithm? Because this algorithm is supervised by the data scientist. Because you are giving the question and you are giving the answer also to the model. Based on the question and answer, the model get trained, it understands the patterns from this, and then apply this pattern on the unseen data. Okay, you are training the model with both input and then labeled output feature. Hence, it is called supervised because we are supervising the model by giving both input and output features to the model. Something like question and answer, if I give to someone, a student, right? So for this question, for this different type of question, this is the answer. You will learn it. Again, for this different, combination of questions, this is the answer. We're giving both question and answer since we are supervising the student, right? We are giving both question and answer. But when I ask the question, which I did not train him, still he should be able to answer it. Okay, still he should be able to answer it. So, the other example is something like, for example, I train a person, 1 plus 1 is equal to 3. I trained him. And 2 plus 1 is equivalent to 3. So the input is, this one, right? 1, 1, 1, and 3, 2, 1. If I ask him 1 plus 2, you should be able to tell it is 3, right? So this is your input, this is output feature. This is your input, this is your output feature. I trained you. This is your input question, this is your answer. This is a question, this is answer. I gave you the input feature and gave the output feature also, label output feature. So if I ask you a question, can you please tell me 1 plus 2? The model should tell correctly 3. Okay, because you already trained the model. The model learned the pattern. Okay, and 1 plus 2 should say 3 only, right? Here we are giving both the input and output features. Hence, it is called supervised machine learning. Unsupervised machine learning. What is unsupervised? Not all the time you will get the output feature. So in that case, uh, you need to use unsupervised machine learning algorithm. So what scenario? For example, you are giving, let's say your customer gave you only this data. They did not give you this data. You work for, let's HDFC Bank. They give all the details, but they say, no, we don't have this data. Label data is not there. So in that case, manually, we need to sit together with the domain expert and understand, we need to write some logic and derive this label output feature. Okay, even, right, so let's say, no, I'm not able to derive this one at all. I don't have the label output feature. That is, so if you don't have label output features, then you cannot train your supervised machine learning model. The only way out is you need to apply the unsupervised machine learning algorithm. Okay, unsupervised. What do you mean by unsupervised machine learning algorithm? Training the model, okay, without the labeled output feature. Okay, without the labeled output feature. The unsupervised machine learning algorithms are helpful. It detects the pattern in your data. It self detects the pattern in your data. So in that case, if I give the data, if I so if I train my model with the unsupervised machine learning algorithm, right? So since I don't have the labeled output feature, if I train the model, what will happen is it automatically segments the data. Let's say you have one group, one segment. One segment or one group consists of defaulters. Other segment contains segment 2 contains non-defaulters. So with that, what you do, right? So the next step is you can take all the customers that are falling in segment 1 or group 1 as your defaulters. You put all the, those customers fall in this segment. You put the Y in this column for this set of customers, and then for this set of customers you need to put n because they're non-defaulters. Okay, so usually in the case of unsupervised machine learning, if you don't have the labeled output features, the only we will resort to unsupervised machine learning algorithm. So in the case of unsupervised, you don't have the labeled output feature. So you can use the unsupervised. It automatically detects the pattern in the data, and then it creates some segments or the groups or clusters. Clusters are nothing but groups. Okay. So in the unsupervised machine learning, what the classic example in the algorithms, right? You have something k-means algorithm. K-means algorithm and hierarchical algorithm, and even recommendation system, and even principal component analysis. You have something called principal component analysis. So these are the algorithms falls under unsupervised machine learning algorithm. Supervised machine learning algorithm. So within the super machine learning algorithm, there are two types. Okay, there are two types. One is the regression problem. The other one is classification problem. Regression problem and classification. There are two types of super machine learning algorithm there. One is the regression problem, other one is classification problem. What do you mean by classification problem? The what we discussed earlier, right? This is called your classification, because here, given the input features, your model, the trained model, when you apply it on the unseen data, it has to classify which category this one falls in. So N or Y. The model has to predict either yes or no, right? So if it is yes means, they are falling in the defaulter thing. If it is no means they are not falling in the defaulter band. Okay, but here, this is called classification problem because the target labeled output feature is categorical variable, categorical column. Okay, and you have another example for the regression problem. In the case of it's a numerical. To solve a numerical problem, That is called solving a numerical problem is called your regression problem. Solving the classification problem is your classification problem. Here we are solving this classification problem. Hence it is called classification problem. Regression problem is something like housing price. Okay. For example, you have input features like size of the house, comma, the second size of the house, and age of the house, and location, and number of bedrooms also. Okay, let's think that. Okay, bedrooms. The size of the house is, let's to 1,800 square feet. Age of the house is, let's 10 years, and location is Navalur. And the number of bedrooms, let's 3 is there. Okay, and number of parking lot is also there, right? Parking lots. Parking lots. Number of parking lots. So let's say you have two parking lot. One is closed, other one is open parking lot. Okay, this is for one house. Okay, likewise, you have lot of data are there in your data. It's, 1 million houses, you have the data. Okay, different one house is 1,800 square, other house is 1,680, 1,786, 96. Different houses, you have lot of houses, 1 million houses data are there like this. These are called your input feature. Okay, and your output feature is, in this case, a numerical variable. Housing price. Predicting the numerical column is nothing but your regression problem. Predicting the categorical column is called your classification problem. Is it clear? That's all here. It's pretty simple. For this specification, the housing prices, let's 2 crore, 2C. And likewise, right, you have n number of records are there. So some houses 1.6 crore, some houses 3.1. Once you train the model learns the pattern. Not only now, almost all the locations in Chennai, all the locations in Bangalore, all the locations in Hyderabad, Pune, Mumbai. If you train your model, right, so your model will learn more patterns. For this location. So for this, right, evaluating the house again, the market driver is also there, right? So if you want to evaluate your model, evaluate your housing price, you can apply the model. That's right. Valuation of your house, right? So here, by giving all these three, all these input features, this is the past data. Okay, in the past data, you took it and you trained your model. When you apply the model on the unseen data, let's say somebody is asking, hey, find 1,600 square feet, 10-year-old house. It's in Navalur, 3-bedroom house, and 2 parking lots are there. What is the expected housing price? If I select what is the expected housing price, I can get it. They say somewhat close to 2 crore. It's a simple common sense, right? So now you are predicting and telling that. So you learned the pattern already. If somebody asks you, slightly, a little bit different specification. 1,000, for example, mine is 1,790 square feet. Age of the 10, Navalur, and 3-bedroom house, 2 parking lot. What is the expected housing price? Right? Because you already trained this model with this data. Okay, and then now you need to apply this model on the unseen data. Nothing like that. See, if somebody comes back, 1,790 square feet, and age of the house is 10, and Navalur, same location, and a 3-bedroom and two thing, right? If somebody comes and if they ask you, hey, you are a data scientist, can you tell me for this specification, what is the expected housing price? What you do is you show this data to your model. Model will tell you the predicted housing. Hey, it's somewhat close, approximately 2 crore. Somewhere close to 2 crore it will give you. Okay, 1.95 crore or something like that, or 1.9697, something like that. Okay. So it will predict this is your predicted value, right? It's a predicted value. This has to be, predicted by your model. Is it clear? Similarly, stock price also, right? You have you want to buy pro and all the things, if you want to forecasting, right? So what you do is you train your model with the past data, and then when you apply the trained model on the unseen data, okay? So what will happen? It gives you the forecasted stock price values for different tickers. We understood there are two types of problems. We solve it in general under supervised machine learning algorithm. One is the regression problem, other one is classification problem. In the case of regression problem, we predict the numerical outcome variable. In the case of classification problem, we predict the categorical outcome variable. One second, I just go here. I lost my PowerPoint because of some problem with my laptop. One hard disk. Okay, one second. I just. Okay, now what we'll do is we'll explore what is a regression problem. Okay, so as part of regression problem we explored it. So in the case of regression problem, we are solving the numerical outcome variable. So here the input features are, it can be a mix of both numerical as well as categorical variable. Okay, both the classification problem, even both the classification problem and the regression problem, the input features can be both numerical. It can be both numerical as well as the categorical column. So this is a text, right? The mix of text and numerical value. Input features can be numerical as well as the categorical column in both supervised, classification problem, regression problem. Regression problem, we are going to predict the number. Classification problem, we are going to predict the categorical value, yes or no, and the madri. Okay, that's all. You just remember that way. So now you learned about the unsupervised machine learning also, and semi-supervised something like customer has given you the data, but only part of the data you have the labeled data is available, right? So for example, they gave you 10,000 records, 6,000 records, they gave you the labeled output feature along with the input features. The remaining records, they did not give the labeled output feature. Okay. That is called semi-super because you don't have the labeled output feature for the entire historical data. Only part of the historical records you have the labeled output feature, remaining you don't have it. So in that case, what we do is we take the records that contains labeled output features separately. Then remaining data, what we do is we use the unsupervised machine learning also, okay? And then we will derive the output feature. And then what we do is we take the entire data and then we train the model, okay? So here it is an hybrid of both unsupervised and supervised, okay, in this example, okay? Next one, reinforcement. It is based on the reward, okay, right? So reward, what you get. For example, you have a hot coffee is there in your cup. Let's say a cup contains hot coffee. What happens is, let's say a kid is there in your house. That kid, seeing that cup contains hot coffee because it can see the smoke is coming out of the coffee cup. So the kid wants to, go and touch the coffee cup. What will happen? When it touches the coffee cup, it feels the heat, right? The kid, cries it first time. Next time, reward and punishment, right? Next time when the kid, when you show the hot cup of coffee, or when you keep the hot cup a little closer to the kid, and if you ask the kid go and touch it, she will not touch. The kid will not touch because last time when I touched it, I suffered. Okay. It's something like punishing and a reward kind of thing. Okay. So if I touch it, it'll burn my finger. No, I'm not going to touch it, man. Enough. I had enough pain. I'm not going to touch it. It's something like based on the reward and the punishment, the algorithm will learn it. So when the kid, right, next time if you keep the coffee, it already learned, right? So this time I'm not going to touch it. Same way, the this algorithm works. Anyhow, we will explore it later point. And I have a beautiful use case for the reinforcement algorithm. Okay, dynamic pricing elasticity. One use case is there. That is the one we'll discuss it later. So you understood what is supervised machine learning algorithm, what is unsupervised machine learning algorithm, and we have seen what is semi-supervised and hybrid of both supervised and unsupervised. And reinforcement is reward and punishment kind of thing. Okay. So based on the, for example, first time, let's the kid try to, let's let's the client, let's you keep a small stool next to the kid. First time it tries to climb the stool, it makes an attempt, it fails, it falls down, cries. Next time it makes an attempt. Likewise, when it keeps tries at one point in time, right? It tries to go and sit on top of the stool. That's the reward. Okay, until it achieves the reward, it keeps trying it out based on the feedback, everything. Okay, initially, no, I made this mistake. Second time, no, I should not do the same mistake. It'll try different way to sit on top of the stool. Second time also, it makes some mistake. The first two mistakes, now it went to the kid's mind. And third time when it tries to, sit on top of the stool, by keeping in mind the two mistakes which he did not, which he did it in the past, right? I'm not going to the same mistake again. This time, somehow the kid was able to sit partially, but again fell down. Now the kid learned three different experiences. With that experience, it is trying to sit again. This time, the kid was able to sit correctly because in the past it learned three mistakes. Now whatever the lessons it learned in the past, right, the mistakes. Now it was not repeating the same mistake. Now it was able to achieve the reward. That means it was able to sit on top of the stool. So this is the algorithm is used in the case of self-driving car. So reinforcement learning algorithm and the computer vision algorithm also they use it. The CNN, the deep learning algorithm, CNN and computer vision also they used it in the case of self-driving car. Okay. So what is machine learning algorithm? If somebody asks, what is your answer? Without writing the programs explicitly, we just train the model with the historical. Train the model is summa and the data காமிக்கிறோம். Historical data, we are going to show it. But the historical data should contain both input and output features. But your model will ask, tell me what are the input features in historical data. Tell me what is the labeled output feature. We tell it explicitly. Once you tell both the input features and then labeled output feature, the model will automatically detect the patterns. Now the question is, without program, without explicitly writing program, now the model can learn the pattern automatically from the historical data based on the input and output feature. Okay, how it learns without writing the program? So someone already invented. ஏற்கனவே ஒருத்தன் கண்டுபிடிச்சிட்டான். Linear regression ஒரு algorithm கண்டுபிடிச்சிட்டாங்க. It's a tested and tried approach. Okay, you don't have to reinvent the wheel. Okay, all you need is just give the input features and output features. That's all. The model will learn the patterns automatically. And then when you apply the trained model on the unseen data, it makes the prediction based on the lessons it learned from the historical data. Okay, so now we understood the two different types of supervised machine learning also, right? The regression problem classification. If you want to predict the target outcome variable, which is a classification or the binary column or the the categorical column, that is called a classification problem. If you want to predict the target outcome variable, which is a numerical variable like housing price, that is called your regression problem. Very simple. What we'll start with the regression problem. So whenever we start the regression problem, right, the first algorithm comes to the first algorithm which we use to learn is linear regression. Okay. So what is linear regression? We use these algorithms to solve the regression problem. Okay. And it focuses on the relationship between dependent and independent variable. Basically, this algorithm gives us a sense of how changes in one individual variable affect the outcome variable. So one individual, so for example, here in this case, if the size of house is instead of 1,800 square feet, it is 1,790. The model will tell you what is the effect of your housing price. Okay. Well, if there is a change in one variable, for example, size of the house, what is the how much change in each drivers will affect the outcome. Okay. So the same example, okay, size in square feet, age of the house, number of bedrooms, area, and number of lights in the house, price. Okay. So the model, so when you give all the 1, 2, 3, 4, 5 columns to your model, trained model, it has to predict the housing price. Okay. And here the historical data consists of the input. So the first one is the input features. The price is your output feature. So based on the number of input features, we are going to predict the housing price. But the historical data contains both the input and output features values. If you see the price, they're given the price here for this set of specifications, right? For this combination of input features, this is the price. For this combination input, this is the price. This is, they call the input features. In some, people, they call the independent variables. This is called dependent variable. So why it is called dependent variable? Price is depending on these factors, isn't it? So obviously, right, if I say the price of the house, somebody is asking us, right, what is the house of this price? If I say 2.5 crore, the next question which they ask is, what is the square feet, mate? 2,000 square feet. Oh, what is the location? Location is, let's say Adyar or Besanagar. Okay, okay. So 2,000 square feet in Adyar and Besan, maybe what you're saying is correct, around 2.5 crore, right? So in this case, the price varies, based on the square feet or based on the age of the house, or sometimes the number of bedrooms also, area also matters, right? So hence, the price is depending on these factors. The price is driven by these factors. What influences the price? These factors. Obviously, right? The input features, importantly, specifically the size of the house and the area, age of the house. These are the one influence the housing price. Higher the square feet and the popular area, the number of bedrooms, three. Obviously, the price is increasing it. The lesser the square feet, lesser the price, and it again depends on the area. Okay. So here we train the model with these input features and output features initially. Once we train this model with the independent variables, input features also called as input independent variables, and the output labeled variable is called a dependent variable. Okay, because the price is depending on these independent variables. Because these variables are not dependent. Only the price is depending on these features. Once we train the main model with the both in the independent and dependent variable or the input and output variable, what happens is when you give new set of data, okay, let's say now your friend comes and asks, hey, you train the model with all the things. Can you tell me what is the output? It's something like, you learned 10th standard math, right? And somebody is challenging you. A ninth standard comes and asks you, can you solve this problem? Because you already learned that problem. Now you will be able to solve the problem, right? But here, right, the problem is you are giving the problem, you are not giving the solution because you do not know the solution. For this specification, what is the price? Because your model already got trained on the input and output variables or individual independent variables and dependent variable. With that, when you show that model this way, it automatically gives you the predicted price. So linear regression algorithm predicts the housing price. In this case, the price is your numerical outcome variable, hence it is called regression problem. To solve the regression problem, we are using the linear regression algorithm. You cannot use the linear regression algorithm to solve the classification problem. This is the one you need to remember at this interview question. Okay, next one is let us understand the type of the relationship. Okay. So if you see a relation of size and so here I have plotted two quantitative variable, numerical variable. Size on the x-axis, price on the y-axis, age on the x-axis, price on the x-axis. And here number of lights and price. Okay, different input features like size, age, and number of lights. I plotted the three different charts in the x-axis. The y-axis price only is there. When you see this one, the size and the price, the line goes in. The line is it's a straight line, isn't it? It's a straight line, but it goes in the upward direction. When you buy a let's say 400 square feet house, it will be, if you draw a line here, maybe right, the price will be like 10 lakhs or 15 lakhs. If you buy 800 square feet, if you draw a line here, right, and here whatever the price is there, for example, here 80 lakhs, something like that. Okay, as the size increases, the price also increases. Is that correct? See, when the size is, let's say, 400 square feet, the price is this much. When the size is 800, the price is this much. When the price is 1000, it goes high. So in this case, both the size and price, these two quantitative variables are correlated, linearly correlated. It has a positive relationship because it goes in the upward direction. Not necessarily the line has to go in the upward direction. There are some cases the size can also, sorry, the line can go down also in the downward direction. As the age of the house increases, for example, 8-year house, well, let's say 5-year house, the price will be more, right? And if it is going to be a 10-year house, the price will be less. If you say 15-year-old, 20-year-old, 25-year-old, the price goes down. As the age of the house increases, the price also goes down. Still, both the numerical variable, quantitative variable, the price and age are correlated. Okay, when one variable increases, other variable decreases. When one variable increases, other variable also increases. This is called positive relationship. When one variable increases, the other variable decreases. That is your negative relationship. There is an inverse relationship. There is a relationship. If somebody asks you the interview, hey, what is the relationship? Are there any correlation exists between these two variables? Yes. But here, there exists an inverse relationship between price and age. As the age increases, the prices decreases. As the size increases, the price increases. There is a positive relation, but here there is a negative relation. But still, both the cases, the age and price and size and price are linearly correlated. In the case of correlation, you are going to compare the two quantitative variable. Remember this. Age is a numerical and quantitative variable. Price also quantitative variable. Size is also quantitative variable. Price is also quantitative variable. Similarly, number of lights is also quantitative variable, and price is also quantitative variable, numerical variable, right? So to compare two quantitative variable, use something called scatter plot, using which we find out the correlation between two numerical variable. Then there are three types of relationship. One is positive relationship, other negative, and no relationship. In this case, if you see, right, see, in general, இப்போ யாரோ ஒருத்தன் கேட்குறான், சார் உங்களுடைய ஸ்கொயர் ஃபீட் என்ன, ஸ்கொயர் ஃபீட் வந்து 2000 ஸ்கொயர் ஃபீட் சொன்னோன்னா ஆப்வியஸ்லி தி ப்ரைஸ் வில் பி மோர். ஏஜ் ஆஃப் த ஹவுஸ்னா 25 வருஷம் ஆயிடுச்சு பண்ணால் அங்கே வந்து அடி வாங்கிடும், ப்ரைஸ் வில் கோ டவுன். ஓகே, அப்புறம் நான் என்ன சொன்னேன், நம்பர் ஆஃப் லைட்ஸ் வந்து நான் வந்து ஒரு 20 பாயிண்ட்ஸ் வச்சுருக்கிறேன்ப்பா, பவர் பாயிண்ட்ஸு. Does number of lights has any influence on the housing price? No, right? அது உன் இஷ்டம்ப்பா, சௌகரியம். எதுக்கு நீ வந்து இவ்வளோ ப்ளக் பாயிண்ட், எதுக்கு இவ்வளோ பவர் பாயிண்ட் வச்சிருக்கிற? That is your wish. Okay, we don't need that many number of power points. So, number of lights, number of power points has no influence on the price. With this chart, we can understand. Straight line தான் என்ன அர்த்தம்? No relationship between these two variables. இசிஜி எடுக்கிறோம், ஒருத்தருக்கு ஒரு பேஷண்ட் ரொம்ப சீரியஸாக இருக்காரு, ஐசியூக்கு எடுக்கும்போது இசிஜி எடுக்கிறோம், ஸ்ட்ரெயிட்ல இருந்தால் என்ன அர்த்தம்? அவர் ஆள் அவ்வளோதான், ஸ்ட்ரெயிட் ஆகிட்டார், அவர் ஸ்ட்ரெயிட்டாக மேலே போயிட்டாருன்னு அர்த்தம். கரெக்டா? ஸோ இங்கே இஃப் யூ சி ஹியர், there is an upward direction, there is a downward direction, but it is not a straight line, right? So it goes up as the one variable increases, the other variable also increases. But when one variable increases, the other variable goes down. So still there exists a relationship between these two variables, but it is a negative relationship or inverse relationship exists between these two variables. This is the one you should be aware before we dive into the further nitty-gritties of linear regression algorithm. Okay, there are two types of linear regression: simple linear regression, multiple linear regression. So as part of supervised machine learning, there are two types of problems we can solve. One is regression problem and classification problem. So regression problem we can use linear regression, but linear regression itself we have two types of regressions are available. Simple linear regression, but in practice, in reality, we are going to use multiple linear regression only because rarely we use only one independent variable, right? The dependent variable only one only, but the input features will be more than one. But if you are using only one input variable, input feature, that is called simple linear regression. If you are using multiple features, multiple input features, and one independent variable, that is called your multiple linear regression. That is what we have seen, right? Multiple input features. This is called multiple linear regression because here one, two, three, four, five input features, multiple input features, and based on which you are going to predict the target outcome variable, housing price. Since we are using multiple input features, this is called multiple independent variable, multiple input features. எல்லாமே same தான். It is called multiple linear regression algorithm. So these are the use cases. If you want to do sales forecasting, customer lifetime value, loss given default on loan, in case the customer defaults, right? What is the expected amount that we are going to lose it? That is what we can predict it as part of this use case. This was consumption and forecasting. How much memory, CPU, in the case of capacity planning, you can use this one. Supply cost forecasting, right? All the things you can. These are the simple examples. Okay. Housing price prediction also we can do that. So this is the equation for the linear regression model. Simple linear regression model. It's very important. The equation for the simple linear regression is y is equal to beta naught plus beta 1x plus e. E is error and beta naught beta 1 is called your coefficient. These are called your coefficient and x is your independent variable. Okay. And here the beta naught beta 1 is called coefficient or it is also called the model parameters. In the terms எல்லாம் நீங்க நல்லா ஞாபகம் வச்சுக்கணும். And x is called your independent variable or some case, right? Some people they call the input feature. Some people they call as the predictor, explanatory variable, causal variables. இதுக்கு இவ்வளவு பேர் இருக்கு. For example, size of the house. It's a numerical variable, right? So the size of the variable influences your y. Y is your housing price. You want to predict the housing price. This is your responsible dependent variable. Housing price, you want to predict it based on the size of the house. Okay. So this housing price is depending on this variable x. In this case, x is your size of the house. So it is also called as independent variable or a causal variable or independent variable polia. Okay, independent variable, explanatory variable, predictor variable, input feature or causal variables. They use all these terms. In addition to that, independent features. Because this feature is not depending on this one. Whereas this one is depending on this one. This y is nothing but housing price. X is your size of the house in terms of square feet. As the square feet increases, the housing price also increases. Every unit increase in your square feet. Obviously, the housing price will also increase. Correct? In this case, we are using only one independent variable. But you might be asking this question, okay? So, okay, in this case, size of the house. For example, I have age of the house. What can I do? So, in this case, you have two independent variables, beta 1, x1 plus beta 2, x2. So x1 is the size of the house, x2 is your age of the house. You can use multiple independent variables. Okay, hence it is called multiple linear. In this case, we are using only one independent variable, hence it is called the simple linear regression. So x is called independent variable or it is also called as explanatory variable or predictor variable, input feature, causal variable. But latest on the most of them they call the independent variable as the input feature. Features, they call the features a labeled feature, okay, labeled variable. Labeled variable and feature. Feature is nothing but the independent variables. Now. You remember that, okay? So that's what I've given an example here. So why is, let's assume there is an housing price. This is what you want to predict it. So the in this case, this is what you want to predict it. How do you predict the housing price? Based on the age of the house or the size of the house. Size of the house is, let's have the 1,000 square feet. You are going to predict the housing price. Okay. But what you do is you need to obtain the value for beta naught and beta 1. You need to compute the value for beta naught, beta 1. And this is your, let's say, forget about age, this is your size of the house. Okay, square feet. Error also you can forget at this moment. Okay. So this beta naught is called intercept. The beta 1 is called your slope. This is very much important. You need to remember this is very, very important. Okay, so you might be wondering, right? If I say square feet, 2,000 square feet, the housing price is going to be 2.5 crore as of now. We know the market value. But still, if I give you different numbers, it's 1,600 square feet. What is the estimated housing price? In that case, you need to multiply the square feet by your slope value, plus you need to add this with your intercept. That is the one will give you the estimated housing price. Got it? See, I just use this equation here. I just explain in a very simple way, and the jar terms what I use very simple one. Is beta naught. Beta naught in the type number B0. I just say B0 is beta naught plus B1 into square feet is the independent variable is square feet. Size of the house. Okay. And here, let's beta naught and beta 1 will be computed by the model itself. We don't have to calculate it. Okay. Let's say the beta naught is 1.2 and beta 1 is, 2. Okay. And the square feet, for example, the square feet of the house is 2,000 square feet. And if you add all the values, 2 into 2,000 is 4,000 plus 1.2, 4,000, 1.2. This is the estimated housing price. Y hat. They call it a Y hat. Y hat is your estimated housing price. Y is your linear regression equation. This is the equation. So with Y, when you plug in the values, beta naught. So how did you get B 1.2? You don't have to worry. See, in the Python, we have some packages are available. Linear regression. When you use the linear regression function, right? It automatically estimates the beta naught value. Beta naught is your intercept, and beta 1 value also you can get it. But manual also you can find out. There are some formulas are available. When the statistical software itself can give you the values for beta and beta 1, why do you need to compare, right? Let's say somebody is asking you, what is it, the housing price for the 2,000 square feet? What happens is it already computed the beta and beta 1, which one, the statistical software, and simply it plugins the value here. And then it tells you 2 into 2,000 is 4,000 plus 1, 4,001.2, sir, if you buy the 2,000 square feet house. Okay, somebody says, minus 1,680, 1,680. Since you have the values for both the intercept and slope, 1,680. So now you multiply these two things. How much? 2,000, 3,200, and 3,360, right? 3,360 plus 3,361.2. That is the estimated housing price for your, the 1,600 square feet of house. You understood? The beta naught, beta 1, right? That is the one will be computed by your model. You don't have to do it manually. And then what happens? It plugins these values in the place of beta naught. It puts 1.2. That is the value computed by the model for the intercept, and the 2 is computed for the slope. It automatically plugins the value, and then it tells, hey, this is the estimated housing price, man. Three thousand three sixty is your housing price. Y hat is nothing but estimated housing price. We use the notation y hat, which is nothing but estimated housing price for this given square feet. For this given 1680 square feet, this is the value that you can, this is the money that you can get it if you sell it. Beta naught is intercept, beta 1 is slope, don't forget it, okay? So if you view this equation visually, right? If you see this equation visually, for example, the another example, okay? In the x-axis I plotted advertisement, y-axis I plotted sales. When you invest more on the advertisement, obviously your sale will also be more, right? When your sales will go high. Let's assume that way, okay? When you invest more on the advertisement, obviously the sales will also go high. Let's say this is your 2 lakhs, 5 lakhs, and 10 lakhs. You just think that way. But you spent 600 $600 or something like that in the advertisement, and the price is the sales is going up. When you invest $800 in the advertisement, so as you increase your advertisement investment, the sales also goes high. Okay, that's what we can see that. So here the advertisement and the sales, right? So this is nothing but for the 200 square feet, the price is 200 comma let's say this 2 lakh, 5 lakh, 10 lakh, something like, okay. For the 200 square feet, the price is 2 lakh, housing price is 2 lakh, or instead not the housing price. Well, if I spend $200 in advertisement, I can expect 2 lakh revenue. Likewise, 200, 300, 400, 500, 600, and 800, right? So with this, visually, if you see here, this is the 200 comma 2, and here, this your 600 comma somewhat, if you draw a line here, right, 4, okay? 600 comma 4, which means for the 600 square feet, 4 lakh sales, the price is selling price, sorry, so we achieved 4 lakh sales, okay? And somebody is asking you, what if I invest $800 in advertisement? What is the estimated sales? In that case, you need to draw a line here, and then you need to draw a line, vertically here, okay, on par with this one, okay. When you need to draw a line horizontally and vertically, okay. So both these lines should the intersect with this line, okay. You need to do it this way, okay. And now, if you see on the left side, if I invest $800, almost 9 lakhs return. Let's that 10 is here. Here 9 is here. So almost I can expect 9 lakhs in revenue. If I invest $800, I can expect 9 lakh revenue. When you draw a line here, okay. Here, what is intercept? What is slope? This is the equation I told you. Beta naught is your intercept. Beta 1 is your slope. Okay. And what is the intercept? The line where it touches the y-axis is called your intercept. Here they have drawn the line in such a way it somewhat closer to all the values, right? All the dots are nothing but the values. Okay, all the values. So this line is called predicted. This line is called your straight line, right? Straight line. This line is called your straight line, which is nothing but your equation. So the y hat. So on top of this line, the predicted values will be there. Predicted values will be there on top of this line. If you draw a line somewhat closer to almost all the values, right? That is called your straight line, best fit line. That is called your best fit line. This red color best fit line is nothing but y is equal. See, I can draw a line somewhere here also, right? Instead of drawing the line in this direction, I can draw a line here. But if you draw a line here, what will happen? These blue color values will be far away from this line. Let's say the line is here, and this is or if I draw a line somewhat here, instead of here, if I draw a line here, this value will be closer to this line, but these values will be too far for this line, right? So what happens is in the case of linear regression, it tries to find out the best fit line. The best fit line is nothing but it covers as many data points as possible, the line, okay? So, or it covers, or it draws this straight line as close to as possible with all the values. Got it? So the line which touches the y-axis is called an intercept. And what is slope? Slope is nothing but the rate of change in y when x changes. This is your y, this is your x, right? What is the rate of change in y when x changes? What do you mean by rate of change in y when x changes? As the amount I increase it, advertisement, amount when I increase it, when I invest more on the money in the advertisement, obviously, what is the, increase in my sales? That is what is slope. Okay. Intercept is pretty straightforward. The line which touches the y-axis is called your intercept. You might be asking this, why the line touches here only? Can't this line touch here? If this line touches here, right, the line will become like this. When you draw a line somewhat like this, right, few of the values are closer to your line, few of the values will be too far from the line. But this line, if you see here, almost all the data points, the blue color ones are somewhat closer to this one, right? You see the distance here, the distance somewhat equal. Whereas if you draw the line here, if you draw the line here, what will, yeah, these values will be closer to the line, but this value will be too far from that line. Okay, so the line which touches, in this case, the line touches the y-axis here. This line is this area, this in the line which touches the the y-axis is called the intercept. There is a formula for the intercept. So beta naught equal to y is equal to sorry, beta naught is equal to the y bar minus beta 1 cap x bar. Okay, this is the one, this is the formula. There is a formula for intercept. Similarly, there is a formula for this slope. Okay, covariance of x comma y divided by variance of x. This we'll see it later. Either you can use covariance of x comma y divided by variance of x, or you can use this formula. Okay, x1 minus x bar and xi minus x bar and yi minus y bar. Y bar is mean. Subtract each x value from the mean and subtract each the sales, right? Subtract each sales value, from the mean. Okay, and the mean of the sales. Okay, and here in the denominator, xi minus x. So the advertisement is 200 minus the mean of these values. You need to square it. Okay, each and everything you need to 200 minus the mean value squared plus 600 minus the mean of the value, mean of this x-axis value squared. Okay, when you substitute all the values, you will get slope. That is what I told you previously, right? The slope is 1.2. Look at in this case 1.2. Sorry, the slope is 2 here, right? Beta 1 is slope. I told you 2 here. Beta naught is 1.2. How did I get these values? With this formula only you'll be getting. Behind the scene, this is what is happened. Okay, now let us move on with. Now, visually we looked at the equation, beta naught, but the predictor values lies on your straight line. That you need to remember. These are your actual values. Blue colors are actual values. The predictor values will lie on top of your straight line. In our case, the red color line is your predicted line or the best fit line. That is where all the predicted values will be there. This is the formula that we use it to get the slope and 1 second. Okay. Okay, no, let's say you are a data scientist or statistician. Now you know what is slope, what is intercept. And you are going to present to the management. Okay, they get confused. What the hell the slope is all about and intercept is all. I'm not able to. Is there any way you can explain it to the layman in their language, right? How do you explain them? So, for example, here beta 1 slope. Okay, if the slope is 2, then y is expect to increase by 2 for each 1 unit increase in x. I just tell you here. Look here. In this example, the slope is 2, right? So what here the slope tells us here, right? The slope is 2. Here the slope is 2, right? So beta 1. I just write it here, B1, so that you should, when you watch the video, should not get confused. Here the slope is B, 2 here. Okay. Let's assume that you plug in the value in the formula and then you get the slope as 2. Okay. And how do you interpret this to the management? When there is a 1 unit, right? When there is an 1 unit increase in square feet, the housing price is expected to increase by 2 times. Correct? That's what is happening, right? When the square feet is 1068, your square feet of the house is 1680. Okay, and right. So in this case, what happened? The slope is 2, right? The y is expect to increase by 2 times of your square feet, right? Square feet. So when there is an 1 unit increase in square feet, okay, this is the one you need to understand very clearly. For example, if I say 1681, I'm going to increase it by 1 unit. So every 1 unit increase in the square feet, the house price is expected to increase by 2 times. Other example is the auto fare. For example, in the Ola, we are booking the auto and it automatically estimates the housing, sorry, the auto fare, right? Let's say Y is your auto fare, you want to predict the auto fare. Y is nothing but auto fare, you want to predict it, that is what you want to predict. And slope is 1.2 and intercept is 1.2. This is a constant value. Intercept is a constant value, remember this. The slope varies for each independent variable. Okay, in this case, this is your number of kilometers. This is your independent or input feature. Let's say here, so 1.2 is the constant value intercept that is estimated by model, and slope is 2 that is estimated by model. Number of kilometers, sorry, kilometers, not Kumar. Number of kilometers. Okay, number of kilometers is if you travel 20 kilometers. Okay, so 20 into 2, 40, 41.2. You just, you think that, okay, this is the estimated, auto fare. So always you say estimated auto fare is 41.2. Okay, if I increase by 1 unit in the in the kilometer, instead of 20, I'm going to increase it to 1. So when you increase 1 unit, right, 1 unit in the kilometer, so your estimated auto fare will increase by 2 times. 2 times plus 1 point. Okay, 2 times. That is what the slope tells us. When there is an increase in 1 unit of your independent variable, your estimated outcome variable y will increase by 2 times in this case. Suppose even if it is going to be 3 times your y will get increased. So estimated y changes by beta 1 for each one. So if the slope is 2, then y should increase by 2 for each 1 unit increase in x. Okay, and next one is intercept. Okay, intercept is something like, if the average value of y when x equal to 0. Okay, and let's say, if beta, no, if the intercept is equal to 4, then average value is to be 4 when x is 0. Okay, now how do I, explain the same with my management about the intercept? Now I am able to explain the intercept, sorry, the slope, right? Slope. Okay, the intercept, how do I interpret that? Intercept. How do I explain it in the layman's term? Same equation. Same equation. But here, for example, here, right, the square feet, I don't have in, let's say the square feet is, 0 here. The independent variable is 0. X is 0 here. Square feet is your X, no, independent variable, okay? So let's say square feet is 0. When the square feet is 0, the expected housing price is 1.2. Sometimes the intercept does not make any sense. Okay, in this context it is not, it doesn't make any sense. See, நான் வீடே வாங்கல என்கிட்ட இருந்து 1.2 lakhs கேட்குறோம் அப்படின்னா நான் ஒத்துக்குமா? Right? So in this case the intercept does not make any sense. For example, there's some sales. Mm, let's say your independent variable is advertisement amount. Sorry, sales இல்ல advertisement amount. You want to predict the sales. Okay. Let's say your manager asks you a question. Okay, sales, for example, in the case the intercept the model predict பண்ணி கொடுத்து beta naught is something like 34.2, which means 34,000, something like that. Okay, and the slope is 2 வருது. And the let's say your manager asking, okay, if I don't advertise anything, what is going to be my sales? That kind of situation, the intercept plays an important role. The average expected sale is 34.2 if you don't invest any money on the advertisement. Advertisement கொடுத்தாதான் எனக்கு sales ஆகுமா என்ன? Even if I don't give advertisement, still sales is happening. But when I invest, when I keep invest more money on the advertisement, my sale is increasing it. That doesn't mean if I don't expend any money on the advertisement, I know I'm going to get the zero sales, right? That is not that, right? So intercept tells you when your independent variable is 0, what is the expected average Y value? Y is nothing but sales. Is it clear? Yes, you are correct. Now you understood what is intercept. The line which touches the y-axis is called your intercept. On the other hand, when the value of x is 0, the average estimated y value is the intercept. In this example, when the an advertisement, which means I did not spend any money, but it still computed the slope value. 2 into 0 is 0, and the intercept value is 34 point. That means the average estimated sales when I don't give any advertisement, and I can expect 34,000. And how do you interpret slope? For every 1 unit increase in the kilometer, you can expect an increase in y by 3 times. The auto fare by, you can expect the auto fare, it will increase by 3 times. So these are the formulas, okay? When you can use different formulas. Either you can use covariant of x comma y to variable of x, or you can use this one, x minus x bar, y minus y bar divided by x minus x bar whole squared. Okay. So x is nothing but the independent variable, in this case advertisement values. Y is your sales, and x bar is your mean of your advertisement, y bar is your mean of your sales. Okay. Now we will see the error now. Okay, best fit line. What exactly best fit line? One second. Oh, okay. So the blue colors are your actual values. The blue colors are your actual values. And when you draw a best fit line, let's it comes something somewhere like this. This is called your best fit line. If you see this value and the distance between the blue color and this red color is the distance is same as this blue color thing, and this line is somewhat same, right? The distance. If you draw a line between this blue color and the red line, in this blue line and the red line, somewhat somewhat similar, right? For example, instead of drawing a straight line here, if you draw a line somewhat closer to these lines, obviously the distance is very less. These lines are fitting, so these values are fitting very well with my line. Okay. But what about this one? This one is too far from this line, right? If you draw a line here, these values are too far from this. Okay, I do one thing. I'll just take the screenshot of this one. I will put it in a PowerPoint. So instead of drawing a straight line here, for example, I'm going to insert a line here. I draw a line somewhere to here, right? What will happen? The width, I'm going to increase it. And the line color is red. If I put, I can draw a line here also. Okay. And similarly, I can draw a line here also, right? You can draw a line here also. You can create n number of lines. But of those lines, which line is your best fit line? Simple here. Okay, what I will do is I will just, yeah. So this is the line I put it now, right? So this is the default line, okay, best fit line I told you. And instead of that, right, you might be arguing this, why don't I put a line here, sir? If you put a line here, these values are a little bit closer, but this is too far from this line. Okay, and this value is too far from this line, right? Or let's say you can draw lines. In this case, this value is very close to this one. That means it is fitting very well to this value. But for this value, it is too far. This line, isn't it? For this value, it is too less. For this value, it is too far. Okay. So the line. That's why I told you what is a best fit line. Best fit line is something like the line which covers as many data points as close to as possible. So this line is close to this one and somewhat close to this one, somewhat close to this one. This line is somewhat close to this value and this line is somewhat close to this value, right? That is what your best fit line. And I told you very clearly, all the predicted value will be plotted on this best fit line. These are your actual value. When you draw a line between the actual and the predicted value, and if you compare, for example, here, see here, so you are predicting in this example, right? You want to predict how many salespersons are required in your store. Okay. If I want to achieve $800 sales on a daily basis, and what is the estimated number of salespersons? Somewhat nine, right? If you draw a line perpendicularly, and then if you draw a line horizontally, right, which is very closer to this one, right? So nine. To achieve $800 sales, how many salesperson that I needed? I need to put nine salespersons. Okay, fine. So if you see here, right, the five, okay, and this is the estimated, salesperson. So the five salespersons are required, but your model predicted, so let's say if you draw here, right, this is somewhat close to, let's say, three. The actual, the salesperson required, is five, but the predicted model predicted, now to achieve this sales, you can, recruit only three and don't not five. Okay, what is the difference between 5 minus 3 is 2. Okay, and then that is the error. Actually, is that one, see, simple. See, if you are a project manager, you know very well. For example, the table is not there here. 1 second, I'll just. Shapes, insert table. Oh, this is the one table. They say, no, the number of steps. Listen, he says, if I put three persons to complete, let's say you want to construct a house, right? Construct the house, let's say two-bedroom house or something like that, okay? You need, listen, also, okay, number of days, estimated days, okay? Listen, you want 2 months, it'll take 2 months time to construct the house, okay? How many number of people are required to construct the house in, sorry, let's say, I am using 4 persons, 4 people I'm using it to construct a two-bedroom house. If I use 4 people, it takes, less than a 4 month time. If I want to construct the house in 2 months, how many number of employees are required? How many people are required? You need to increase the number of employees, staffs, right? Number of people, right? So how much here? If I write 4 people are required per month, that means each month one person. So if I want to construct the house in 2 months, how many people are more people are required? How much are required here? Hmm? Roshan, this is what my model has to predict, right? How many people are required here to do this one? So 8, very good, right? 8 people are required. 8 staffs are required. Eight people are required to construct the house in 2 months' time. Okay, so that is what we are estimating. But what is the reality? This is what the predicted value. What is the actual value? To run the 4 month, 5 people. We ended up putting 5 people, and with 5 people, we were able to complete the thing. This is the actual, and this is the 2 month. Actually predicted 8, but what happened? End of the day, right, we end up 10 people. With the 10 labors, I was able to construct this is your actual. இது வந்து actual is your predicted. What is the error here? Prediction error. நம்ம இதுதான் predict பண்ணோம். This is what we forecasted, but we ended up these values. What is the error? 5 minus 4 is 1. 10 minus actual minus predicted, right? So 10 minus 8 is 2. Error is 1 in this case, but in this case, the error is 2. If the error is 1 here, that means the accuracy is high. Lesser the error. So actual minus predicted. அதான மேனேஜர் நம்ம பண்ணுவோம் இல்லையா? ப்ராஜெக்ட் மேனேஜர் என்ன பண்ணுவோம்? What is the actual effort? What is the estimated effort? To complete a task, ஒரு web application, mobile application develop பண்ணோம். To develop a mobile application, right? So I need, if I put 4 people to develop a mobile application for my e-commerce website, they take 4 months to complete. Okay, so if I put, that is what my estimated thing, right? I'm going to estimate to develop my mobile app. So it requires 4 people to complete it in 4 months. Okay, this is what, but actually, right, I ended up 5 people to complete the mobile development. I ended up 5. I predicted 4, but the reality is 5 people I put it. So 5 minus 4 is 1. That is the error. My prediction accuracy is not correct. I predicted 4. Ideally, I should have predicted 5, right? The actual also 5, the predicted also 5. 5 minus 5 is 0. That means the accuracy is very good. But in reality, you will not get, 0 error. Okay, 0 error. You understood? With this example, I just type it here. Please consider, guys, this is not, okay, this is a predicted or estimated, number of people. Here, the actual. This is our actual minus predicted. So in this case, it is 2. Okay. For example, if the actual is 9, so actual minus predicted is 9 minus 8 is 1. That means the error is less. Lesser the error, the predicted accuracy is good. Okay. I just put it here 9 போடலாமே 9 days. Sorry, 9 people. I ended up 9 people. That is the actual thing, but the predicted was 8. But the difference between actual and predicted, 9 minus 8 is 1. Actual minus predicted is 1. This is very important, okay? So 1. That means, right, the error is there. It's not, the actual and predicted not exactly same, right? Actual and predicted is not exactly same, right? It will not be exactly same in most of the cases, okay? Ideally, you want to reduce the error, okay? So in this case, 9 minus 8 is 1, okay? That means the lesser the error, okay? Error is there, but the error is less here. Actual means predicted is nothing but error, guys. Look here. Here the predicted values lies on top of the line. The actual values are this one. The difference between actual and minus predicted, you need to square that value. Okay, actual minus predicted வந்து இங்க நீங்க ஸ்கொயர் பண்ணிக்கணும். Why? Supposing you get, for example, actual is 8 and the predicted is sorry, the இப்போ நெகட்டிவ் வேல்யூனா என்ன பண்ணணும்? Let's say your actual is 9 and the predicted is 10. Okay, predicted is 10. அப்போ வந்து 9 minus 10 is minus 1. So what you do to avoid that negative value, right? So you need to add all the values. So if you add plus 1 and minus 1, for example, இங்க வந்து I just put it 10 here. Sorry, here I put 9 only. Here I put 9, but here predicted was 10. In this case, the predicted value is more than my actual value, and I know my error is minus 1. I need to add all the values. Okay, this value and this values. This is called sum of squared error. So in this case, you need to square these values, actual minus predicted, because if you square these values, minus 1 and minus 1 will become plus. Okay, it will give you the effect of the error, right? Total error. But if you subtract these values, what will happen? 1 minus 1 will become 0. அப்புறம் வந்து there is no error மாதிரி ஆயிரும் இல்லையா? So in the standard deviation we saw, right, we need to square the values. Similarly, here also we need to square the values. Okay, you need to square the values. So 1 squared is 1 and minus 1 squared is plus 1. So the error is 2. So here 1 is 1 squared is 1, minus 1 squared is 1, 1 plus 1 is 2. The error is 2. Okay, so for that reason we are squaring it. So for each and every actual value, we are subtracting from the predicted value actual and predicted whole square. Error 1 squared, error 2 squared, error 3 squared, error 4 squared, error 5 squared. And if you add all the error, that is what your sum of squared error. Okay, sum of squared. If the sum of squared error, right, is lesser, okay. For example, if you draw this line, what is the actual and predicted value? What is the error, right? If you square each and every error, for each and every point, if you compute the error and if you square it, you will get some value. For example, 124 வருது. But if I draw a line here, அதுக்கு you are trying to find out the actual and predicted value, and you are going to compare this line's sum of squared error with this line sum of squared error. Whichever line sum of squared error is less, that is called your best fit line. We can say that way also. புரிஞ்சுதா இல்லையா? For example, instead of putting a line here, if I put a line here, what will happen? And here format shape, and here I just go and increase it to this big, and line color is red. Instead of putting a line here, if I put a line here, what will happen? The predicted values will lie here, right? So the difference between the distance between actual and predicted value will be too far. But for this value, right, the actual and predicted value is very less, right? The error is less, but for this one, the error is more. And if you square the error for this line, right, the sum of squared error, you get 124. And if you square the sum of squared, here in relation 144. Which one is lesser? 124 less or 144 less? 124 less. The line which gives lesser error, that is called your best fit line. We can say that way also. Okay. Now, the error is also called as a residual, right? Residual for the sample data. If you find with the sample data, if you fit a model, that is called residual. If you use the population, that's called your error. Okay, but in general, right, both of them are same. Error nalam onnudha, residual nalam onnudha. What is the formula to find out the error or residual? You subtract the predicted value from the actual. That is called your residual. If you square this value, actual minus predicted whole squared, that is called sum of squared error or squared error. And if you sum the each and every error squared, that is called sum of squared. So what is the best fit means? The difference between actual and predicted values is a minimum. Okay, but positive difference of set the negative ones. Okay, offset the negative ones. Positive differences offset the negative ones, and ls minimizes the. It is also called least squared. The least squared. Least squared error. Okay, least squared error. That means minimizes sum of the square differences. Sum of SSC na sum of squared error. Okay, that is what. Whichever line sum of squared is less, that is the best fit line. Okay. So we are just visually looking at it instead of looking at this way. Instead of looking at this way, when you look at this, right, when you visually look at it, so this is your actual value. The blue colors are your actual value. The brown color, முன்னாடி brown color பார்த்தோம்ல, இந்த brown colors are your predicted value. The predicted value. This is the blue color is your actual value. The predicted value is your brown color. The difference between actual and predicted is one square. இங்க இதுக்கு ஒரு data point தானே இருக்கு. Multiple data points are there, right? This is your error 1 squared, error 2 squared, error 3 squared, error 4 squared. Why are we squaring it? Because we need to add all the errors. When you add all the errors, the plus and minus should not get subtracted. Okay, I want to add all these values so that I will get to know the total error. Okay, so I don't want to suppress the error. I don't want to underplay the error by subtracting the values. Right, for this line, what is the sum of square? And again, you put another line here and find out the distance between actual and predicted. And in whichever line has lesser sum of squared error, that is my best fit line. So actual minus predicted whole square the error squared. And if you sum each and every error squared, that is called sum of squared error. They may ask you this question, what is the best fit line? Right, the difference between actual should be very less. That is what your best fit line. Okay, so the model actually takes care of it. But still, if the model takes care of everything, then what is the job of see the equation yaro kandupidichitom already. Someone they invented the equation already, and statistical softwares are there. Right. So then, if it identifies the best fit line automatically, right, on its own, then what is the role of data scientist? Even a 10th standard guy can also learn this one. He can also fit this one. He need not to invent something new. It will not be the best fit line will not be always good. So as a data scientist, it is our responsibility to minimize the error as less as possible. And the fine tuning that is where the data scientist plays an important role, a crucial role. Now you understood, I explained you the simple linear regression and multiple linear regression also explained you. Okay, now if you use multiple independent variables to fit a model, regression model, that is called multiple linear regression. Or if your model contains more than one independent variable, that is called multiple linear regression. If your model contains only one independent, that is called simple linear regression model. And also we know the equation for the linear regression model. Let's start with the simple linear regression model equation, which contains only one independent variable. So beta naught y is equal to beta naught plus beta 1 x. Okay. So x is the independent variable, only one independent variable is there. So beta naught and beta 1 is also the model parameters, or it is also called as a coefficients. The beta naught, beta 1 values will be computed by the software itself. We don't have to compute it. Okay. So what is exactly the intercept? Beta naught is nothing but intercept. So how do you how is this helpful? The intercept value is constant. In some scenarios, the intercept does not give any meaningful thing. Okay, for example, in the case of auto fare, if my x is zero, x is, for example, number of kilometers traveled is zero, but my intercept value is 12. If even if I don't travel, do I need to pay 12 rupees, right? But that one may be applicable because if you cancel the auto, right, you're not traveling it, you're canceling still they are charging who Uber. In this case, it is maybe it makes sense. Even if I don't travel, will I be charged? Yes, because you cancelled it. For example, in the case of housing price and square feet, if the square feet is zero, the estimated housing price is 12,000. You will get frustrated, right? You will get angry. So in that case, intercept does not make any sense. So what exactly intercept is tells us when the value of x is zero, the independent variable value is zero. What is the average what is the estimated average value of y? Other example on the sales, right? If I don't spend any money on the advertisement, the x value will be zero. Zero into the slope value is zero, and my intercept value is less than 34 point something like that. So the average estimated price of or sales of the average estimated sales is 34.2. In that case, it makes sense. And also the intercept plays an important role when you do encoding in your linear regression model. Encoding, we will see it in the next session. Okay. No, at this one, okay. How do you interpret the slope? For every 1 unit increase in x, what is the estimated, no, what is the expected change in y? Supposing the slope is 2 and there is a 1 unit increase in x, the estimated value of y will increase by 2 times. They say that 2.2 means 2.2 times your y value will get increased. That's all. It's very simple. Any questions so far?